A quick new idea daily from the world's greatest TEDx Talks. I'm your host, Atosa Leone, and this is TEDx Shorts. How can we learn about Earth's history and the future of our environment? Meghana Ranganathan says we should look at ice, specifically our changing Arctic ice sheets. How will this affect our planet and how soon? Meghana is a PhD student in climate science at MIT. Today, she shares the story of our shared glacial history and why the movement of ice is something that should concern all of us.
Glacial ice is made up of snow that's been compressed over time by the weight of new snow falling on top of it. And as it compresses, it traps things. It traps air. It traps debris like volcanic ash. It traps whatever was in the atmosphere at the time. And those impurities remain trapped in our atmosphere for hundreds of thousands of years. And they tell us about the past. Scientists go up to Greenland and they drill cores of ice. And in these cores, you can see distinct layers that tell you when that snow fell. And scientists can sample all of those impurities to try to reconstruct past atmospheres, past climate shifts, and even past human shifts. We'd like to think that the evidence of our history is preserved. And in a similar way, we'd like to think that our ice sheets and our glaciers are a constant presence on Earth, not only one that's been around for all of human history and will continue to be, but also one that doesn't change or move quickly. Today, we have satellites that enable us to create whole maps of the speed of our ice over all of Antarctica, for example. And we can see that in Antarctica, our ice moves in these narrow bands of fast-flowing ice called ice streams. And my personal research is trying to understand what causes these ice streams to form, why the ice within them is moving so fast, and why some of them are speeding up. Of course, our ice doesn't just flow. It breaks. And our ice sheets don't just lose mass steadily. They change dramatically. And this is something we're only just starting to understand. We thought our ice sheets changed on a geologic timescale, on timescales of tens of thousands to hundreds of thousands of years. And we have had to dramatically rethink this notion in the last 20 years, because we're just starting to see how fast our ice sheets can change. Many of you might remember the breakup of the Larsen B ice shelf back in 2002. An ice shelf is a tongue of ice that floats on top of the ocean, but remains attached to the ice sheet on the mainland. And back in 2002, a section of this ice shelf the size of Rhode Island disintegrated. How fast can our ice sheets change? One of the big questions right now is Antarctica. So Antarctica is a continent made up of a bed of rock and sediment and an ice sheet that sits on top of it. Recent evidence suggests that the West Antarctic ice sheet might be at risk of collapse entirely. So when we ask this question, how fast? We're not just asking how fast our ice moves. We're asking how fast our ice can break. What causes our ice to break so fast? And how can we predict when our ice is going to break? Now, what does this mean for the future? In the coming decades, we as a society are going to have to contend with this question of sea level rise, much like our climate and our landscapes had to contend with the same question of sea level rise at the end of the last ice age. And it's becoming increasingly apparent that to understand our future, we have to understand the future of our ice.
The TEDx talk you just listened to was recorded at a TEDx event in Boca Raton, Florida. All TEDx events are independently organized by volunteers who believe in TED's mission of ideas worth spreading. Special thanks to the organizing team at TEDx Boca Raton. Want to listen to more TEDx talks? Explore the entire archive on the TEDx YouTube channel. I'm Atosa Leone. Thanks for listening, and see you tomorrow.